Derivation of combination of lenses. Let's draw the diagram. See, we have two thin convex lenses in contact, and let's draw the principal axis, and a point object is placed at the principal axis. The first one is lens L1 and the second one, let it be L2. Let the focal length of the first lens be f1 and the focal length of the second lens be f2. To study the combination of lenses or combined focal length of two thin lenses in contact, we have to assume that only the first lens is present. Let us assume only the first lens is there. The second lens is not present. So, for the first lens, the ray passing through the optical center goes undeviated, and the ray incident on the surface of the lens L1, after refraction, it would produce an image at I dash. Okay, so for the object distance u, the image is formed at I dash. So the image distance is v dash. But due to the presence of the second lens, the final image will be formed somewhere here, and this will be our final image I. So the final image is, we have image distance v. See, due to the presence of I dash, so here I dash acts as a virtual object. Now the final image is formed at I. So for the first lens, the object is O and the image is I dash, and for the second lens, the object is I dash. That means the object distance will be v dash and the image distance will be v. This you should be clear. Now let us see, for the first lens, what will be the lens formula? It will be 1 by f1 will be equal to 1 by v dash minus 1 by u. Let this be our first equation. For the second lens formula will be 1 by f2 will be equal to 1 by image distance, v is the image, minus object distance is I dash is the virtual object. I dash is the virtual object. So it will be 1 by v dash. But see, in this diagram, the object is at O and the final image is produced at I. So this image distance is not required. So we can remove these two terms. How will we remove? So we can adding equation 1 and 2. What it will imply? See, this is plus and this is minus. Both these terms will go. So 1 by f1 plus 1 by f2 will be equal to 1 by v minus 1 by u. Okay, this is our equation number 3. See, suppose, see, I am going to replace the combined effect of these two lenses by a single lens. Now I'm going to replace the two lenses with a single lens. I can call this lens as an equivalent lens. Equivalent lens. What is an equivalent lens? An equivalent lens is a single lens that forms the image of an object at the same position as is formed by the combination of lenses. So, see, by the combination also the image was formed at I, having the same image distance V, and the object distance was also same. So, this lens can be called as the equivalent lens. So, if you apply the lens formula for equivalent lens, we get 1 by f will be equal to 1 by v minus 1 by u. Okay. So this is image distance and this is object distance. Now, if you compare the equation number 3 and 4, we get 1 by f1 plus 1 by f2 will be equal to 1 by f, where this is the equivalent focal length of the combination of lenses. So the equivalent focal length is 1 by f is equal to 1 by f1 plus 1 by f2. Now, combined power of two thin lenses, or we can say equivalent power of the two lenses. The equivalent power is, again, we have derived the equivalent focal length is 1 by f is equal to 1 by f1 plus 1 by f2. So we know power is 1 by f. That means the equivalent power will be P1 plus P2. So it keeps on adding. See, we can say P is equal to P1 plus P2 plus up to Pn. How much combination we are making. Same way, this equivalent focal length also 1 by f is equal to 1 by f1 plus 1 by f2 plus up to 1 by fn. After deriving combination of two thin lenses, we get some important results. So let us have a look at those results. See, case 1. See, we derived when both lenses were convex. When both lenses were convex. So the result was the combined focal length 1 by f is equal to 1 by f1 plus 1 by f2. Here plus. When both lenses are convex, the combined focal length is 1 by f1 plus 1 by f2. Case 2. If one lens is convex and the other is concave, we all know the focal length of convex lens is positive and the focal length of concave lens is negative. So, for our convenience, let us always assume f1 be the focal length of convex lens. This will help you in solving numerical problems also. f2 be the focal length of concave lens. Then what will be the combined focal length? It will be 1 by f. That is, the combined focal length is equal to 1 by f1, focal length of convex lens, plus 1 by minus f2, because the focal length of concave lens is negative. That means we can write, this implies 1 by f is equal to 1 by f1 minus 1 by f2. Again, we arrive at certain results. See, if f1 is greater than f2, if f1 is greater than f2, we can just substitute and find that the focal length, combined focal length is negative. So, in this case, the combination of the two thin lenses will be behaving like concave lens. It will be behaving like concave lens. In the next case, we see if f1 is less than f2, if f1 is less than f2, then f is positive. The combined focal length will be positive. In this case, the combination will behave like convex lens. The combination will behave like convex lens. And the final condition, if F1 and F2 are equal, then the combined focal length will be infinity. That means the combination will behave just like a plane plate. For better understanding, let us solve a simple numerical problem. See, let me read the question. The focal length of a concave lens is 20 centimeter and the focal length of a convex lens is 25 centimeter. These two lenses are placed in contact with each other. So what is the power of the combination? We have to find out the power. Is it diverging? Diverging means concave lens, converging or convex lens, or undeviating in nature. So we have to determine whether it is a diverging or converging lens. So I told you the focal length of convex lens we are taking as f1 and it is positive. So it is plus 25 centimeter. Again, the focal length of convex lens, let it be f2, it is minus because the focal length of concave lens is negative. So it is minus 20 centimeter. So applying the combined focal length formula, we get 1 by f will be equal to 1 by 25 minus 1 by 20. If you solve, we get 1 by f will be equal to minus 1 by 100. Minus 1 by 100 centimeter. That is, the focal length will be minus 100 centimeter. See, that is in SI unit it will be minus 1 meter. Minus 1 meter. Here the negative sign signifies the focal length is that of concave lens and concave lens is a diverging lens. So we got the answer. It is a diverging lens and the focal length is 1 meter. Now coming to the next part of the numerical, power of the lens system. So we know the formula. Power is 1 by f. We have found out the combined focal length. It is 1 meter minus 1 meter. So I can write power will be equal to 1 by minus 1. Actually 1 meter means 1 diopter. So it is minus 1 diopter. So the power is minus 1 diopter.